Bismillahirrahmanirrahim. Quote of the day by Qaid-e-Azam Muhammad Ali Jinnah. I insist you to strive, work, and only work for satisfaction with patience, humbleness, and serve the nation. Today, my topic of presentation is my years of dispersion under the supervision of Professor Dr. Zahra Afzal. In this presentation, I would be discussing basic definition of dispersion, what are the objectives of dispersion, what is range, interquartile range, standard deviation, variance, and coefficient of variation. At the end of the presentation, the participants will be able to describe the basic measures of dispersion, their interpretation, and application. So what is dispersion? Basically, dispersion refers to the variation of items among themselves or around an average. Greater the variation amongst different items of series, the more will be the dispersion. And as per Bowley, dispersion is a measure of variation of the items. This is the basic definition. So this is the graph showing two graphs separately from 2000 and 2015. The graph from the year 2015 is more broad as compared to the graph from year 2000. So the graph that is made from the data collected in year 2000 is said to be good data, as it is closer to the mean, the dispersion is less, and it is more accurate and more generalizable to the population as compared to the graph taken from the data from year 2015. So what are the objectives of measuring dispersion? First of all, the first objective is to determine the reliability of an average. Second, to compare the variability of two or more series. Third, for facilitating the use of other statistical measures. And fourth, the basics of statistical quality control. So what are the properties of a good measure of dispersion? A good measure of dispersion is easy to understand, simple to calculate, clearly defined. It is based on all observations collected as a part of the data, not affected by extreme observations, and capable of further algebraic treatments. So here is a classification for the measures of dispersion. It is mainly classified into two categories: absolute measures and relative measures. Absolute measures consist of range, quartile deviations, mean absolute deviations, standard deviations, while the relative measures are coefficient of variation, coefficient of quartile deviation, and coefficient of mean deviation. I would like to explain each and every one in detail in my coming slides. So, as already explained, the methods of measuring dispersion, we can use range, interquartile range, mean deviation, standard deviation, coefficient of variations, and I'll slightly touch what is Lorentz curve. So what is range? Range is the simplest measure of dispersion. It is defined as the difference between the largest and the smallest value in a series. Like range is largest minus smallest values. And the coefficient of range is obtained when we divide the value by obtained by from largest minus smallest plus largest value plus smallest value. So it is a practice problem. A data is given and we have to find the range. By applying the previously mentioned formula for question number 1, the range comes out to be 20 and the coefficient of range is 4.4. Easily you can calculate it for the second data set for which the range comes out to be 60 and the coefficient is 0.75, and find the range and coefficient of range for third data comes out to be 25 by applying the same formula for largest minus smallest and then the coefficient of range by using the previous formula. So what are the merits and demerits of range? Range is a simple to understand, easy to calculate, and widely used in statistical quality controls. Demerits is that can't be calculated in an open-ended distribution, not based on all the observations, and affected by sampling fluctuations. And it's also affected by the extreme values or the outliers. Now, what is interquartile range and quartile deviation? Interquartile range is difference between the upper quartile and the lower quartile, and it covers the dispersion of middle 50% of the items of the series. Symbolically, we get interquartile range by subtracting the upper quartile Q3 from the lower quartile Q1. And quartile deviation is half of the interquartile range. It is also called semi-interquartile range, and we get it by dividing the interquartile range by 2. Similarly, by having the coefficient of quartile deviation, it is the relative measure of quartile deviation. And coefficient of deviation, we get it by dividing similarly to the coefficient of range by dividing the obtaining the values from Q3 minus Q1 and then dividing it by Q3 plus Q1. So in this problem, in question number 1, we have a data set starting from 28, 18, 20, and these are the values. And we get the interquartile quartile range by applying Q3 minus Q1, and similarly the quartile deviation from the similar formulas, and from question 2 and 3 can be done with similar formulas. So what is mean deviation? Mean deviation, the average of the absolute values of deviation from the mean. Median or mode is the mean deviation. It is calculated from this formula where m bar x is the average values of the data set, n is the number of data values, and xi is the data values is in the sets. So what are the merits and demerits of the mean deviation? The merits is that it is simple, based on all values, and less affected by the extreme values, but it is but inaccuracy and not capable of algebraic treatment and unreliable are the demerits. That's why we do not use mean deviations for more frequently. Now comes to the standard deviation. In our daily life, we see articles, we use this term very frequently in our thesis, in our synops, whenever we are doing any kind of research. So I would like to explain it in detail. What is standard deviation? What are the applications of standard deviation? How we can use standard deviation in our daily life? And what is the importance of standard deviation, and merits and demerits? So it's the most and the widely used measures of dispersion, and it was first used by Carl Pearson in 1893. And it's also known as the root mean square deviation. So a standard deviation is defined as the square root of the arithmetic means of squares of the deviation of the values taken from the mean. It can be either sample mean or the population mean. Whenever we are using a population mean, then we use the symbol sigma, and then the formula is under root, that is summation xi minus mu. Mu is for the population mean, and divided by n, that is the total, that is the size of the population. Here are the other formulas. Whenever we are using a sample standard deviation, then we use the symbol s, that is for the sample standard deviation. And in denominator, you can see there is a difference for population standard deviation and sample standard deviation. In sample standard deviation, we use n minus 1. The reason for using this n minus 1 while calculating standard deviation, that when we use n minus 1 in denominator, it corrects the bias. And the bias is because we are using the sample mean instead of the population mean. So to calculate the variance and the standard deviation, we use n minus 1, and this n minus 1 is so the sample variance or the standard deviation will be so called the unbiased estimator of the population variance. Why is the standard deviation important? Things like heights of the people in a particular population tend to be roughly follow a normal distribution. So standard deviations are important here because the shape of the normal curve is determined by its mean and standard deviation. And the mean tells you where the middle, the highest part of the curve should be. Either it would be fall on the center close to the mean, or the curve should be skewed, either negatively skewed, positively skewed. Here is the graphical representation of a normal distributed curve with showing area under the curve in reference to the standard deviations. The graph is divided into two halves. The portion on the left side shows -1, -2, and -3 standard deviations, minus, and on the right side is total +1, +2, and +3 standard deviations. The total area under the curve covered between plus minus 1 standard deviation is 68%. Then minus plus minus 2 standard deviation 95, and then plus minus 3 is 99% area is covered. Mostly we use plus minus 2 standard deviations. Why is the standard deviation important in research? This is a question that popped in my mind as soon as I heard the term standard deviation. So in research, standard deviation tells us about the shape of our distribution, how close the individual data values are from the mean values. Standard error tells how close our sample mean is to true mean of overall population. Together, they can help to provide a more complete picture than the mean alone can tell us. So while interpreting interpretation of the standard deviation, whenever the standard deviation is low, like we say that the standard deviation is low, then low standard deviation means the data are clustered around the mean. High standard deviation like +3 or shows that a high standard deviation indicates the data are more spread out. Hence, a standard deviation close to zero indicates the data points are close to the mean. A high or a low standard deviation indicates that points are respectively above and below the mean. So here is an example to just clarify how is standard deviation used in real life. We can also use standard deviation to compare the two sets of data. For example, a weather reporter is analyzing high temperature forecasted for two different cities. A low standard deviation would show a reliable weather forecast. So there is an application of standard deviation also in real life. So what are the merits and demerits of standard deviation? Merits is that standard deviation is based on every item of the distribution, and it's possible to calculate the combined standard deviation as well with the mean. For comparing the variability of two or more distribution, coefficients of variation is considered to be the most appropriate, and it's also used most prominently used in further statistical work. And demerit said compared to others it is difficult to compute, and it gives more weight to extreme values and less to those with near to mean. So here is an example of an auto sales in which the variance and the standard deviation for the European auto sales for a sample of 6 years is given, and the data to be calculated, and the data are given in millions of dollars. So first of all, for this we are using the sample standard deviation formula. We make this table with first we get the means, then they're the values, then the mean, then we minus x bar, and then we get the square of these means. We apply these values in the formula, and we get standard deviation of 1.13. For finding the mean, ahead, this is a low standard deviation, and in the next example I would explain the high standard deviation. In this we are giving the population mean. Find the mean respiratory rate per minute and its standard deviation when in 4 cases the rate was these are the values 16, 17, 22. And the mean is calculated by sigma x over n. It comes out to be 17. Then we get d by x minus x bar and d square by squaring the values, and then adding them all to get summation d square. Then we get the square root of these values by dividing by first we divide sigma x minus x bar square over n, and then we get the value 3.2. So it's a high standard deviation, and the values lies far from the mean. Now, what is variance? Variance, it is another measure of dispersion. It's the square of the standard deviations, and variance is denoted by standard deviation square or sigma square in case of population standard deviation. The variance is described as a measure of variability. It is calculated by taking the average of squared deviations from the mean, and variance tells you the degree of spread in your data set. The more the spread the data, the larger the variance in relation to the mean. Hence, the variance is the average square deviation, and both measure standard deviation and variance reflects variability in distribution, but the units differ. Standard deviation is expressed in same units as the original values, and the units of variance are squared, so they are meaningless. So when calculating the population standard deviation, the sum of squared deviation is divided by n, and then the square root of the result is taken to eliminate the effect of this squared value. Next is the coefficient of variation. It was developed by Carl Pearson, and it is an important relative measure of dispersion. It is used in comparing the variability, homogeneity, stability, uniformity, and consistency of two or more series, and higher the coefficient, very less the consistency. Here is how to calculate the coefficient of variation. For sample mean, we say sample divided by x bar and 100 multiplied by 100%. And for the population, it's sigma over mu and 100% in divide multiplied by 100. What are the advantages of coefficient of variation? It's useful because standard deviation of the data must always be understood in context of mean of the data. The coefficient of variation is a unitless number. So when comparing between data sets with different units or widely different means, one should use the coefficient of variation for comparison instead of standard deviation. But here are also the demerits that when the mean value is near zero, the coefficient of variation is sensitive to small changes as mean and limiting its usefulness. Now I'd like to touch a little about what is Lorentz curve. It was developed by Maxwell Lorentz in 1905 for representing inequality of wealth distribution. The curve is a graph showing the proportion of overall income wealth assumed by the bottom X percentage of the people, although this is not rigorously true for the finite population. Here is the curve. On x-axis, we have cumulative share of people from lowest to highest incomes, and on y-axis, we have cumulative share of income earned. There is a line of equality, and then the Lorentz curve is shown by the line B. So how to interpret this curve? The question is, how is Lorentz used to measure the poverty? The answer is that if there was perfect equality, if everyone had the same salary, then poorest of the population would gain 20% of the income. It is in the perfect situation, but it's not applicable all the time. And if the poorest 60% of the population would get 60% of the gain in an ideal situations, but it can vary. It can be higher than the line of equality, and it can also be lower to the line of equality. So I just wanted to just give a brief description of what's Lorentz curve and how it's used and how it's applied in real life. Now it's time for MCQs. MCQ number 1. The standard deviation is affected by value of every dash. Complete the sentence. By relative dispersion, observation, absolute items.
Observation. B.
Observation.
Yes, standard deviation, as I already told, is affected by the each and every value in the data set. Now, which is the poor measure of dispersion in an open-ended distribution? A quartile deviation, semi-interquartile range, or none of these?
Range.
Yes, range is a poor measure of dispersion whenever we have an open-ended distribution, because range is calculated when by subtracting the largest value from the smallest value. So in an open-ended distribution, we cannot use range. It's a poor measure of dispersion. The sum of all squared deviations is divided by total number of observations to calculate what? Population deviation, population variance, sample deviation, sample variance.
Population variance.
Yes, the right answer is right. Population variance. The sum of all squared deviations is divided by the total number of observations to calculate, and if we get the under root of it, we get the population standard deviation. MCQ number 4 is, if the arithmetic mean is multiplied to coefficient of variation, then the resulting value is classified as coefficient of mean, coefficient of deviation, standard deviation, or variance.
Coefficient of deviation. B.
No, the answer would be standard deviation. If we multiply arithmetic mean with 2 coefficient of variation, then the resulting value classified as standard deviation. The measures used to calculate the variation present among the observations in the unit of the variable. Then we call them as relative measures of dispersion, coefficient of variance, absolute measures of dispersion, and coefficient of skewness. As
Absolute
I have
measure of
Yes, as I have mentioned, the observations in unit of the variable. So whenever we are using the same units for and a measure of dispersion, then we use absolute measures of dispersion that includes the standard deviation and the like the quotient of variation and coefficient of skewness and relative measures. It's not necessarily that the observations are in units of the variable. Which measure of dispersion has different unit other than the unit of measurement of values? Range, standard deviation, mean deviation, variance. As I've already told while describing variance, that in variance it's a unitless meaning and its units are meaningless. So in this case, the answer would be variance. In 7 MCQ, an automobile manufacturer obtained data concerning the sales of 6 of its deals in the last week of 1996. The result indicates the standard deviation of their sales equals 6. If this is so, then the variance of their sales equals A, B,
A.
C, sorry. Square variance is squared deviation, so it would be 36. Answer is D.
36.
Yes, the answer is 36 as the variance is the square value for the standard deviation. So the answer is 36. Which of the following measures of dispersion is expressed in the same units as the units of the observation? Variance, standard deviation, quotient of variation, quotient of standard deviation.
Standard deviation.
Yes, the answer is standard deviation because it's the absolute measure of standard dispersion. So the answer is standard deviation. Answer is B. Here is the key and references, and thank you so much.